Okay, in this fourth problem of the set on rectangular and trapezoidal approximation, we have this table of values. The rate at which water flows out of a pipe in gallons per hour is given by the differentiable function r of time t. The table above shows the rate as measured every 3 hours for a 24-hour period. First, we want to use a midpoint Riemann sum with 4 subdivisions of equal length to approximate the integral from 0 to 24 of r of t dt. Using correct units, then explain the meaning of your answer in terms of water flow. Well, if our whole interval is from 0 to 24 and we want to break that down into 4 subdivisions of equal length, obviously 24 divided by 4 would be widths of 6. And then we want to use the midpoints as the height of each subinterval. So 10.4 would be the height of the first rectangular area and its base would be 6. 11.2 would be the height of the second rectangular area and its base would also be 6. 11.3 would be the height of the third rectangular area and its width or base would also be 6. Finally, the fourth will have a height of 10.2 and its base will also be 6. So if we were simply to add up all of the heights and then multiply that value by 6, it would be the same. And that would come out to 43.1 times 6, which from our calculator is 258.6. And so therefore we can state that the integral from 0 to 24 of r of t dt is roughly equal to 258.6 gallons. And this would be the amount of water that has flowed through the pipe in the 24-hour period. Alright, so we'll go on to part B now. Part B asks, is there some time t between 0 and 24 such that r prime of t is equal to 0? We need to go to our theorems for this, and it happens to be that Rolle's theorem states that when Rolle's theorem says that if a function is continuous on a closed interval and if it's also differentiable on the open interval from a to b, and if f of a equals f of b, then the derivative will be 0 for some c between a and b. So what we want to look for here, our f of x happens to be r of t, and we want to look for, first of all, we're told that r of t is a differentiable function, therefore it's going to be both continuous and differentiable. Next, all we have to look for is some starting and ending point that have the same value of r of t, and it turns out that r of 0 is 9.6 and r of 24 is 9.6, and so that satisfies Rolle's theorem, the requirements for Rolle's theorem. And so we state that since r of t is differentiable and since r of 0 equals r of 24, then r prime of t is equal to 0 for some value of t between 0 and 24. Alright, we'll go on to part C then. And in part C we have a function that can approximate the rate of flow of water. And we want to use that function q of t to approximate the average rate of water flow during the 24-hour time period, indicate units of measure. So the average value of a function, since we're looking for the average value of the rate of water flow function, we just want the integral divided by the interval. The time interval is 24 hours, so it's 1 over 24 times the integral from 0 to 24 of q of t dt. We're going to bring up the graphing calculator and set up the function q of t. So we have 1/79th times the quantity 768 plus 23x minus x squared. And we'll want to take the integral of that from 0 to 24 and divide the result by 24. So we go to math, fn int, and y1 comma x comma 0 to 24, divide the result by 24, and we end up with 10.785. And this is meant to be the average flow of water, and you can look in the table and see that 10.785 is a very reasonable answer, and so that does it for this problem.